Hello, hello, welcome to class. We are going to be discussing Chapter 1, Lesson 3, Measuring and Constructing Angles. Before we get started with the first example, what I want you guys to do is I want you to do this warm-up. Problem 1, 2, 3, and 4. So now it's time for you to go ahead and pause your device, work out those 4 problems, and then when you get done, press play and we'll go over the answers. All right, see you in a bit. All right, we're back. Let's go ahead and see how you did. So this first one says draw, that's a ray, AB and ray AC, where A, B, and C are non-collinear. So remember, a non-collinear means they are not in a straight line. So I'm going to draw AB right here, and you might have something a little bit different, but it's the main idea. So remember, the end point is right here. So this is A, and it's going off in the direction of B. And then I'm just going to have AC, so A is also the end point. So I'm just going to have C go this way. And there's the A, and here is C, like that. So those are 2 rays. They share that common endpoint of A, and they're non-collinear because you can't draw a straight line through all 3 of them. Perfect. Okay, number 2, it says draw opposite rays, DE and DF. Okay, so opposite rays, look at, you can see that endpoint is D, right? So here we have D, and one ray, let's have it go this way, and we'll call that one E. And then the other ray, F, it's opposite, so it means it's going in the opposite direction, which would be right there, and we call that F. So 2 opposite rays sharing a common endpoint always form a straight line. All right, let's go ahead and solve these equations. So let's get those algebraic juices flowing. Okay, we want to get x by itself. So we're going to have to combine like terms. Here we have 2x, x, and 3x. So that's 2x plus x is 3x plus 3x is 6x. So I'm going to end up with 6x, then I'm going to combine the numbers. 3 minus 4 would give me a -1, minus 5 would give me a -6. So there we have it. Double check. 2x, that's 3x, 6x, good. And then that, if I go this way, that would be -9 plus a +3 would be -6. Okay, great. And then we're just going to go ahead and solve. So trying to get x, I have to do the inverse operation of this -6, which would be an +6 to both sides, the addition property of equality. 6x equals 186. And then we want to get this x by itself. It's 6 times x. The inverse operation of multiplication would be division by 6 to both sides. 6 divided by 6, that's 1. 1 times x is x. 186 divided by 6, I'm not quite sure, but I can go over here and divide it really quickly. 6 goes into 18 3 times. 3 times 6 is 18. No remainder. Drop down the 6. 6 goes into 6 one time. 1 times 6 is 6. No remainder. Boom. That's the answer, 31. So if you got 31, great job. All right, let's go ahead and do this one. 5x plus 2 equals 8x minus 10. Here we have variables on both sides. We need to get them on the same side. I always like to move the smaller. The smaller is 5x. So I'm going to subtract 5x to both sides. 5x minus 5x ends up being 0. Now I have 2 equals 8x minus 5x is 3x minus 10. Right? So we're going to add 10 to both sides. 2 plus 10 would be 12 equals 3x. We want to get x by itself, so we're going to do the inverse operation of we would divide by 3 to both sides, and we get 12 divided by 3, which would be 4 equals x. And I always like to use that symmetric property of equality and get that x on the left side. So if you got a 4, great job. All right, so let's actually move into the content. After that little warm-up and our brains are flowing, let's go ahead and talk about some different vocabulary. So the first one is an angle. An angle is something which is a figure formed by 2 rays or sides with a common endpoint called a vertex. So a figure formed by 2 rays or sides with a common endpoint. So if we go back up here to this warm-up problem, we had two rays, right? There was AB and AC, and they had a common midpoint of A, and that ended up being an angle. And right here, this A would be called a vertex. So that common endpoint is called the vertex of the angle. Okay? Here we go. Here's another one. Interior angle. What an interior angle is, that is the set of all points between the sides of an angle. So the interior is the set of all points between the sides of an angle. So if I was looking at this example over here, the interior would be everything inside. Any points inside this angle would be interior. Exterior points, now those are all the points on the outside of the angle. So if we have our angle here, everything on the outside would be considered exterior points. So all of these around here would be exterior. So we have the angle names. Here we have an angle. Let's go ahead and write down all of the angle names for this particular angle. So whenever you're doing an angle, you can just call this angle R, like that. Or you can use these other points and call it angle S, R, T. But notice that the vertex is always in the middle. Or you could do it the other way and call it TRS. But notice the vertex is always in the middle. You couldn't do this, RST. The vertex is not in the middle, so that would not work. You cannot write the angle like that. You can call it angle R, or the vertex always has to be in the middle. There's also this little 1 here, and so you could call this angle 1 as well. So those are 4 different ways to write the same angle. Okay, which leads us to our first example problem here. Example 1 says, a surveyor recorded the angles formed by a transit, point A, and 3 distant points, B, C, and D. What we're going to do is we're going to name 3 of the angles. Okay, cool. So an angle that I see, and I think let's just go ahead and name a bunch, all right? An angle I see is BAC. So BAC, that would be one, BAC, or I could do the reverse, which would be angle CAB. All right, that would be one set. What about this right here? This angle right here, I could go CAD. So angle, you always have to use this angle, CAD, or I could do the reverse, which would be DAC. Angle DAC. And notice how this vertex is always in the middle. It has to be like that. Okay. Oh, what about this big one? We have this big angle here, BAD, just the whole angle. So we could call that angle BAD, or the opposite, which would be DAB. Angle DAB. Now, could we call this just angle A like we did in the previous example? Well, with this problem, if you could see angle A, do we know if I just say angle A if we're talking about this angle, or the big angle? We don't. That is not specific enough. So in this example, we couldn't just call it like that. We could, over here, we could call this just angle R, right? Because there's only one angle there. So if I say angle R, you know exactly what I'm talking about. Over here, if I say angle A, somebody could think I'm talking about this small angle, somebody could think I'm talking about this other small angle, and a third person could think I'm talking about the big angle. So it's not specific enough since there's so many angles. So when that's the case and you have a lot of different angles going on, you have to use this particular format for identifying the angles. Okay? So how about you go ahead and try this one. Write the different ways you can name the angles in the diagram. So go ahead and write all the different ways you can name it. So go ahead and pause, work that out, write them all down. When you get done, press play and we'll go over them together. All right, we are back. Let's go ahead and write all these angles. So I see this one right here. I see 1, 2, and then a big one, right? So let's just go ahead and write all these down. So I'm going to start with this top smaller one. So that could be angle QTR. Remember that vertex T has to be in the middle. So QTR, or we could say RTQ. Angle RTQ, and you always have to use that angle. The last way I could talk about this one is just by calling it angle 1. And if I say angle 1, it's different than angle T because 1 is right there in that angle. So if I say angle 1, you know exactly what angle I'm talking about. Okay, so those are 3 different ways to write this particular angle. Let's go ahead and write this bottom one. So the first thing would be RTS, angle RTS. The next one would be the reverse, STR. STR, and then, or you could write this right here, angle 2, like that. Okay, so that's 3 ways to write this little angle. Were you able to get all 3 for that one? What about this top one? Okay, so let's write the big one now. So the big one would be QTS. Always remember that vertex is in the middle. So angle QTS. And then the reverse would be STQ, angle STQ. And that's it. Those are all the only examples. We couldn't do anything with a number because there's not one number for that whole big angle. So that's it. 1, 2, 3, 4, 5, 6, 7, 8. Were you able to get all 8? If you did, good job. All right, we will see you back with example 2 in a little bit.